Hey there guys, it's the average computer science student here, and today we're going to be looking at an introduction to object-oriented programming. As you can see, we're going to be starting out small. I don't claim to be a genius, that's why I call myself the average computer science student. Uh, I feel like I have a pretty good grasp of this, but this doesn't mean I'm going to be explaining everything just like a textbook would. I just kind of like to explain it in a way that humans can understand. So, without further ado, let's dig into it. Object-oriented programming. What is it? Well, object-oriented programming is a programming paradigm, which is just a fancy way of saying it's a way of programming. It was upgraded from the procedural programming paradigm. Essentially, procedural programming is just reading the program will start at line 1 and it'll end at line n, and it'll execute lines in order, do while loops, for loops, whatever, but it just does things in a procedural order, goes straight down from the top. Well, the object-oriented is kind of different than that, in that it puts code into little objects, which are then executed not necessarily in a procedural order. So why would you use object-oriented programming? First of all, it makes the code easier to follow. This is kind of an opinion, but it's kind of a common convention, common understanding as well. Whenever you understand object-oriented programming, it also will apply in most situations. So it just kind of allows it to be a little bit easier for everyone. And a big thing as well is it has code reuse. It saves time, which saves money, which pretty much everyone wants to do, especially from a business standpoint. It's another good thing that I actually don't have written here, but you're going to see it in our example later, is that it object-oriented, the majority of the time, maps really well to the real world. So we're going to go over that in a little bit later video, or a little bit later slide. In fact, I think it's the next slide, but it maps to real life. So what is it? Let's see it. Let's get down to thinking about it. Now, this isn't an exact example, but this is a conceptual understanding of it. So, object-oriented program begins with classes and objects. Classes are blueprints. They're like the design for what an object will be. The object is the instance of a class, so what the blueprint made. So a really good analogy that I was taught whenever I was learning this is you can compare classes to recipes in the culinary arts. So let's say that we have a blueprint or a recipe for making cookies. Well, that recipe would tell you everything that you would need. It would tell you like the different ingredients that you would need, and once you ended up making that, it would also give you instructions on how to cook it. So it may have a data member called ingredient 1, and ingredient 1 is sugar, and ingredient 2, I don't know how to bake cookies, but I'm going to say it's chocolate chips, and a method of it may be that that's how to cook it, so you can stick it in the oven. A method in real life maps to things that can be done with that object. You can eat a cookie, so there's a eat method. So going away from that is essentially what to take away from that analogy is classes are like the blueprints, which are like recipes, and what is made from that recipe is the instance of the class, or it's the object. So going back to our cookie example, the object, once it's made, there's an eat method, because you can eat a cookie, or, I mean, what else can you do? You can dunk a cookie in milk. That would be a method that maps to real life. We can program that as well. So you'll see a little bit better of an idea once we actually dig into the code, which is what we're going to do in a few seconds. But this is just a basic conceptual idea, and I recommend that pause the video, think about this for a minute before we go on to the actual thing, the actual programming, because you really do need a good conceptual idea of this before you get going. And it took me a long time to figure this stuff out, so don't expect to get it immediately as well. Just try to spend some time thinking about it, looking at it. Whenever the video's done, maybe try your own few examples, mess around with the numbers, and see if you can't get yourself a good idea about how objects work. But without further ado, let's take a look at an example. So as I said, we have an example here where we're using C++. Now this is a very quick example, but we're going to go through it, and you can do this in any language. It's just I like C++ because C++ was designed to be object-oriented, and because of that, it's kind of like, it's just nice to use. So the first thing, as I said, we have our recipe right here. We have our rectangle class. So what we're going to be defining here is what a rectangle should be. Now, inside of any C++ program where you're going to be doing input and output, you just do this include here, and using namespace std, you can look that up if you want to know exactly what that is, but it's outside the scope of this lecture. So, rectangle is a class name. We can name that whatever we wanted, but intuitively, the great thing about objects is that they map to real life things. So why would you name it, cheese if it's going to be a rectangle? You would name it rectangle, of course. And what we're really doing is we're creating a data type called rectangle. So, a lot of things you don't need to worry about too much either. Is this public and private? Essentially, in a rectangle, any rectangle that you make will have its own private data members and have public data members and public method. So to map that back to our cookie example, a private data member of that may be exactly how many chips, chocolate chips, is on that cookie. You can't edit that. Now, as the baker you can, but let's just pretend that you can't. Once the cookie is baked, you can't add or remove those chips. You don't want anyone messing with that number, so that's why it's private, and that's essentially the only way to access that is through methods, which once again we're going to talk about in a moment. And then there's the public, which is the one that the outside world is allowed to do. So what we are setting up here is, first of all, we're going to have data members. And an object can have data members, which are just properties that define that object. So in the case of cookie, it may have a data member, shape round, shape triangular. You can make cookies different way. Color brown, color white. It can have a color. It can have, I think that's pretty much it with our cookie example, but you can map to anything. Well, what does a rectangle have in real life? Well, it's kind of boring, but it has a width and it has a height. And that's pretty much it. So those are rectangles' data members. Now, methods, if you've heard of functions, a method is just a function that is inside of a class. A method is something that an object can do. It is a function that an object can do, which is called a method. So what should our rectangle be able to do? Well, as I said before, this is a private data member, so we can't just have them changing the width and the height willy-nilly, because they could set the width equal to -2. And then what are you going to do? It's going to break. So this is why these are private, and they have to go through our methods here. And this is very common convention. We're going to be going through what's called getters and setters. And this is just C++ syntax right here. You can look it up. It's very simple, but essentially it's always handled this way. Whenever it is a method, you essentially put the data type, and then it expects parentheses, and the parentheses tell it that it's a function, or rather a method in this case, and what that method may take as or has to take as a parameter. So we're telling that there's going to be a set width method. There's going to be, and it's going to have no return, it's void. We're telling that there's a set height method, which will also, both of these are taking in an integer as a parameter, which is also going to not return anything. And then the getters, so that is setting the width and setting the height. And the getters, it will return an integer of getWidth, which doesn't need any parameters because it's just going to return the width, and then getHeight, which is a function as well, but you can tell by the parentheses, or a method rather, which will return an integer, and then getArea. So what are these? These are just things that we can do. First of all, every data member, if you're wanting it to be changed, should have a getter and a setter. And furthermore, we want to also have a method that gets the area. So, all of that being said, this is still just the blueprint for that object rectangle. So, let's go down a little bit further. And remember, this is just C++ syntax. Not every language will handle it like this, but I just think this gives it a really good map. So right here, Whenever we close this class off, we've told it what the class is at a high level. So now we have to tell it what these methods are. So we told it to expect a setWidth method. Well, it has to know what that is. So you go down a little bit and you were setting, the same. We declared it was going to be a void up here. So we say it's going to be a void here. Now what is this right here? What is this? Why do we have to declare it like this? Well, the truth is we don't. But if you're ever going to be putting things in multiple files, which is kind of why C++ is made, then you will be using this. So I'm going to go ahead and explain it now. What this is this is called a scope operator. So if I were to remove this right here and just put void setWidth, int x width equals x, and run this program, it would work without any issues. Oh, actually it might throw an error, but anyway, essentially this would not get us what we want, because this setWidth, first of all, it has no idea what width is, because this scope operator tells it, hey, if I tell you to look for something and you have no idea what it is in your local scope, so if it's going to see this width, and it's going to say, I don't know what width is, but it has this scope operator that says, hey, look inside of this class and see if there you find a width. Well, that's what the scope operator is saying. You're telling it that you're explaining further this class. So right here, the scope operator says to look inside of the rectangle class for any data members used on here that it cannot find. So if we write a piece of code that runs this, creates a rectangle, and then uses the setWidth command and gives it an integer x, if x is 3, it's going to know that it doesn't have a local width. So it's going to look here and see if it has a width. And it does right here. Now we can, this is why the reason that you would do getters and setters is to do some sort of check on it to be sure that it matches. So we can say, if if x is greater than 0, then set it. Oops. So essentially it will only set the width if the width that they're trying to put in is greater than 0. So if they could directly edit this width, then they may try to put, like I said before, -2 in there, which would explode because that is not possible. So we can set this in here saying it has to be greater than 0, and of course we could add like some sort of else that's couts. And this is just C++ syntax, but essentially it's just going to, if x is greater than 0, oh wait, yeah, if x is less than 0, it's going to hit this right here. And so you come to the set height, and it's kind of the same deal. You're telling it that to look inside of the rectangle for the set height method, and like it doesn't have a local copy of height, but it does know that this has a height, and so you would set it to whatever x is. And then you got to set up the getters. So those are really easy. It's returning an integer, so you return width, and like I said before, it knows to look here for width, because if it just typed in width inside of this local scope, there's nothing to do with width. But up here we do have a width, and it's the same with the height. You return the height, and then what is the get area going to do? Well, it's going to return the width times the height, because that's what the area of a rectangle is defined as. So now let's test it. Let's just run a quick test of that. So let me get rid of this for now. What are we doing right here? Well, just in C++, whenever you are defining a variable, you put the variable data type first, and then you give it a name. So right now I just created an integer called cheese. Well, essentially I'm doing the same thing here. I'm creating a rectangle with the name testRectangle. Now, testRectangle is more than just your basic primitive data types. It is a object. So, testRectangle is the completed cookie. It is cooked. It is the instance of the class. So we can then call on its methods, and it has its own data members. So right here, what are we doing? TestRectangle.setWidth to 2. Well, it's going to, test rectangle is a rectangle. So it's going to call this setWidth function, and it's expecting an integer, and I gave it the integer 2. It's going to come here, and it's going to take that integer and say, is x greater than 0? It is. So it's going to set the width equal to x, which in our case is 2. Same thing with the height. And so now I just have a quick cout, which is going to tell us, using the getters, what the data members are set equal to. So the way that we access the data members and the methods is using dot notation. You say test rectangle dot a method, or the name of your object dot one of its methods, or the name of the object dot a data member. Now if it's not private, if we created a public data member here called int pub num, we could set that directly. So this will set test rectangle.public number pubnum equal to 4. Now, as you can see, as I said before, if I would have let them directly set the width, it's not going to have any problems with me sending that -4. And it would have a problem if it tried to figure out the width, or rather the area of something that has a negative sign. So that's just to reiterate the reason behind that. So I'm going to get rid of that public number. Okay, so what do we expect to happen here? Well, it should print out the width, because it's going to cout test rectangle width, and then you can do test rectangle dot get width, and so it's going to call upon this method right here, which is going to return the width, and it's going to put a period after it, and do that for the height, and do that for the area. So let's see if it runs. So as you can see here, as we expected, it shows the test rectangle width is 2, the height is 5, and the area is 10. So right now you may be asking yourself, okay, well this is a whole lot of steps to do things that I can do in a way that doesn't use class and method, or class and all these object type things. So what is the point of doing that? Well, to kind of illustrate its power, let me get rid of this stuff. You can create another rectangle. Now, you do not have to rewrite any code. Everything is built the exact same, and you could set its width and its height to completely different numbers. So, test rectangle 2 is now a rectangle as well. And test rectangle 2 doesn't have any idea what test rectangle 1's width and stuff is. It has its own data members. It has its own width. It has its own height. So if we run and compile this, you can see here that the area of the first triangle is still, or rectangle is still 10, and the area of the second rectangle is 30. So I hope this gives you a quick down and dirty, but maybe explain object-oriented programming. If there's any questions or anything, feel free to ask, and I will try to explain those to the best of my ability. It is a difficult concept, and the best way to learn is just to get in there and just try to start thinking about ways to make it work. Think of different objects in real life and then try to put them into code. So, you know, any geometric shape is a really good place to start, and that's actually where a lot of video or a lot of guides, even on the C++ website, will show you how to start. In fact, I pretty much took this right off of the C++ website. Now, this is not entirely the entire spectrum of object-oriented programming discussed here. There's a lot more that you can do, and this is just a quick introduction to allow you to kind of get going. So if you have any questions, feel free to ask, and I will try to help you out with that. But good luck and happy coding.